We're going to move on to chapter 6, and it deals with geometry. The next couple of chapters deal with geometry. So if you look on page 335 of your handbook, is that right? No. In your student journal, it's just 6.1. Sorry, I'm in the wrong book. What's the page number? 187? Okay. So on page 187, you see this. Come on. And up at the top it says, how can you prove a mathematical statement? A proof is a logical argument that uses deductive reasoning to show that a statement is true. One of my issues with English class that I've always had is there are rules in English, but they're always broken. Right? Rules in English are kind of most of the time correct, and then sometimes they're not. For instance, when you spell words, do you put the E first or the I first? I before E except after C, but any word that has a German origin doesn't follow that. They put E's before I's. And I've heard, I haven't actually looked at it very closely, but I saw an article once that they counted up all of the words where I was before E, and then all of the words where E was before I, and it turns out that little rhyme is wrong more often than it's right. So there are exceptions everywhere. And one of the problems with language is you have to define things. Right? Every word needs a definition. But how do we define words? Using words. So the dictionary is full of definitions of words using words. Do you guys see a problem with that? At some point, you're going to go around in a circle. For instance, define what it means to be happy. Well, you have to pick some other word that means happy. Okay, some being glad or having joy or ecstatic or in a good mood. Well, what if you define in a good mood? Then you eventually you're going to have to come back to the word happy. Right? So every word in the dictionary is defined using words from the dictionary. So we end up with this big circle. In mathematics, we don't like that. We make definitions, and then we agree on certain rules, and then we prove that things are true. And in mathematics, there are no exceptions. If there is an exception, it's actually just a rule. So we need to start proving that things are true in a way that it makes sense and in a way that we don't end up relying on a big giant circle like we do in English. So this exploration number 1 says, 4 steps of a proof are shown. Write the reason for each statement. Okay, so in this proof, we are given that line AD, and when you just say AD, that means the distance between point A and point D. So line AD, this line right here, has a length that's equal to line AB plus AC. So basically what we're saying is the blue line is just as long as the red line plus the green line. That's given. Okay, that picture has been drawn, and that specific quality has been told to us. And in most proofs, we are handed some sort of given, something we already know coming in. Okay? And the question basically says, prove that CD is equal to AB. So we want to prove that this length is just as long as this length. Okay? And we're starting off with a proof where they tell us the steps. We just need to decide why the steps are true. So this is a two-column proof. In a two-column proof, on the left side, you have a series of statements. So each one of those things is true. And then on the right side, you have a column of reasons. And those reasons back up the statements. So those reasons need to describe how you know that the statement on the left is in fact true. So, in a two-column proof, you almost always start with the given. So we are saying that AD is equal to AB plus AC. How do I know that's true? They told me. Okay, the problem told me that that was true. Or in some other cases, it will just be something that's so obvious that we just write given. Okay, and so we know that this length here is equal to this length plus this length. Okay, and then the next statement says AC plus CD is AD. So it's saying that this length there plus this length there is equal to this length there. Would you agree that's true? How do I know that's true? So look at this picture again. So the red line, the distance of the red line plus the distance of the green line is equal to the distance of the big black line. How do I know that's true? How would you describe that? What's that? So we're basically looking at two parts of a continuous line. Okay? So for our reason, let's put this. How do I want to say that? The parts add up to the whole. And there are a lot of things you could put right there. You could put that they're two pieces of the same line. When you add two distances together, they equal a larger distance. But that one's pretty obvious, right? That AC and CD are just as long as AD. And then your job is to write the explanation. How do you know that that's true? And there are a whole bunch of ways to describe that. I have chosen parts add up to the whole. Okay? Now, how does that help us? Well, our goal is to show that this length here, so that length there, is equal to that length there. That's the point. How are we going to do that? Well, let's think about it abstractly. So I have this distance with points here. The only thing I know is that this length plus this length is equal to this length. Okay, I know that. So if I take the red line and the green line, then it's going to be just as long as the black line. Okay? That's what I was told. What I want to show is that this length here is equal to this length here. How am I going to do that? Okay, so something with the green line. Good. If I take the red line and I subtract off the length of the green line, then I end up with this little piece here. That little piece is this little piece here. Okay. And then this piece right here is equal to this piece right here. How do I know that? Because the green line is actually created there, and the red line is actually just this piece, right? But the green line also fits here. Oops. Let me draw it again. The green line also fits there. Do you guys see that? So if I cut that piece off, then this piece and that piece are going to be the same length. Does that make sense? Okay, so let me do it again. I have this. Okay. I know that this length and this length add up to the whole length. Everybody agree? Okay. So if I put, oh my goodness, let me do that differently. Sorry. That's not what I wanted to do, nor is that. Let's try that again. Okay. I know that the red length and the green length add up to be the black length. Everybody understand that? Okay. So if I take the green length and put it here, I end up with the whole piece. Right? Okay, but I also know that if I take the red length and subtract it off of the green length, this length right here represents that length right there. Agreed? Okay. But if I flip this over, oh, that blue thing was supposed to come with it, then that blue is in the same place. Agreed? So now this lines up with that, and I already showed that this piece and this piece are the same size. Does that make sense? Okay, so let's go back to our proof. So we said AC plus CD equals AD. So AC plus CD equals the whole length. Okay, we know that. Now step 3 says AC plus CD. So A to C plus C to D, so this length plus this length, is exactly the same distance as AB plus AC. How do I know that's true? What's that? Right, so this right here is the whole length. Okay, so the whole length is AB plus AC. That came from the given. So all we did was substitute. So my given says AD from here to here is equal to that plus this. Well, I just substituted. So where the AD used to be, I put this in its place. So basically I'm saying AD is equal to AB plus AC. But instead of using AD, I used the given. And that's just called substitution. So I stuck this in there. And the reason is substitution. Okay. And now number 4, that tells us that CD is equal to AB. Now this is a little bit tricky, so let me help you out. Okay, I know that this plus, well, let's do it. So that right there plus that right there equals the whole distance. Okay, that was given. And then I said that this right here and this right here also equals the whole distance. Agreed? So now I have, well, let me make this one black. So now I have red plus green equals the whole distance, and blue plus black also equals the whole distance. So I should be able to put the red and the green together and make the whole distance. Right? But if I arrange it the other way, no, that's how I wanted to do it. What do you notice? If I put it this way, the red and the black are in exactly the same place. Okay? Does that make sense? It's kind of a confusing one to start with. I probably would have done an easier one. So let's look at the symbols. So I took this and I put it here. Now look at the symbols. AC plus CD is equal to AB plus AC. What can we do to this to show that AB and CD are the same length? You guys see it? There are two ACs. So we're basically saying something plus CD is equal to AB plus the same something. It's like saying, let's say 4 plus, well, that's a bad idea. Let's do A plus B is equal to B, oh my goodness, A plus B is equal to C plus A. Well, what do I know about B and C? If A plus B is equal to C plus A, then B and C have to be equal. So for this one, all we have to do is take off the AC. So just remove the ACs. Let's move on to the next one. So take a look at this. Now we have an angle. Okay, we have this picture. We have B on the vertex, and then we have points A, C, D, and E. And there are two ways to name an angle. If an angle has a number on the inside, like this angle here, then we could just write angle, that's the angle symbol, 1. Or if you wanted to talk about this angle, that would be angle 3. But there are several angles in there that don't have numbers. For instance, this angle. If an angle doesn't have a number, then you name it according to its points. And you always put the vertex of the angle in the middle. So that could be called angle ABD. So we travel from A through B over to D. Or it could be named in the opposite direction, angle DBA. And notice in both instances, B is in the middle. So whenever you name an angle according to points, you always put the vertex in the middle. And ABD and DBA are exactly the same angle. It just has two different names. Okay? So, given angle ABD is equal to, and you see those M's? Those M's mean the measure of angle, whatever. That just is talking about how wide they are, what their degree measure is. So the measure of angle ABD, so ABD, this one right here, is equal to the measure of angle CBE. So this angle right here, prove that 1 and 3 are the same size. Okay, so I know that this angle is just as big as that angle. And we want to prove that 1 and 3 are the same size. Okay? Now, we're missing some of the statements, so we'll have to do statements as opposed to reasons. Okay, so the measure of angle ABD is equal to, right here, the measure of angle 1 plus angle 2. Right? So the measure of angle 1 plus the measure of angle 2 is equal to ABD. And they wrote the angle addition postulate, which is a really fancy way to say the two parts add up to the whole. It's pretty obvious, right? 1 and 2 add up to that green angle. Okay. Now, CBE is equal to what? Angle 2 plus angle 3. So this angle right here is equal to 2 plus 3. So the measure of angle 2 plus the measure of angle 3. And they write the angle addition postulate. I'm not going to make you write the angle addition postulate. That one's just obvious. Two parts add up to the whole. Okay? All right. Now, what would we put for 3? Well, the reason says given, so it has to be our given. So the measure of angle ABD is equal to the measure of angle CBE, and that's given. And notice that the given in this case is on the third line, and that's okay. You could have put it on the first line, but they have chosen to put it on the third line. So now we've created two basic stories, and here they are. this angle here, so the black angle, is created 1 plus 2. Okay? And then the second storyline is the blue angle is created using 2 plus 3. Well, how is that going to help? Well, nope, that's not what I wanted to do. If I take this and slide it up there, they both have a 2 in them. You guys see that? So if 1 plus 2 is just as big as 2 plus 3, what does that tell us? 1 and 3 have to be the same. So if we look here, okay, 1 plus 2 is just as big as 2 plus 3 because our given says that the black angle and the blue angle are the same size. So the black angle is created using 1 plus 2, and the blue angle is created using 2 plus 3. Then line number 4 says 1 plus 2 is just as big as 2 plus 3, and that's just substitution. Right? ABD is 1 plus 2 because of this line right here. And then the next one, CBE is 2 plus 3 because of this line right here. So I'm just building this proof step by step. I said the black angle is 1 plus 2, and then I said the blue angle is 2 plus 3, and then I said the black angle and the blue angle are the same size, which means that 1 plus 2 and 2 plus 3 are the same size. And if you look there, they both have a 2. So if I get rid of the 2's, I'm left with the measure of angle 1 is equal to the measure of angle 2. Does that make sense? Oh, 3? Sorry, you're right. There we go. Measure of angle 3. Does that kind of make sense? All right. Okay. Go to page 190 in your workbook. And we have this. Here's another proof to practice. So, complete the proof. Given angle AEB is a complement of BEC. What does it mean to be complementary? You ever heard that? Complementary means they add up to 90. Supplementary means they add up to 180. So basically, this angle here and this angle here add up to 90. So on my little picture, I'm just going to write a 90-degree angle right there. Okay? Prove that AED is also 90. Okay? So I want to prove that this angle is also 90 degrees. Okay? So I'm going to start with my given. AEB plus BEC is 90. That's a given. Okay? Which tells us that what it says definition of complementary angles. What would you put for number 2 statement? What does it mean to be complementary? 90. So this would be the measure of angle AEB plus the measure of angle BEC equals 90 degrees. That's what it means to be complementary. So the given is that they're complementary, and our step 2 says if they're complementary, then they add up to 90. Okay? Well, this says that the measure of angle AEC is equal to AEB plus BEC. What's that? How do I know that this angle is equal to this angle plus that angle? So if you look at the picture, how do I know that the big angle is equal to this one plus this one? It wasn't told to us, but I know it's true. So how do I know that two angles next to each other add up to the whole angle? Two parts equal a whole. Yeah. So I would just write parts equal the whole. Okay. So parts equal the whole. And they probably would put the angle addition postulate. We're not talking about the angle addition postulate. Okay. So we know that the measure of AEC is 90 degrees. How come? What's that? Yeah, so you could say parts equal the whole. You could use substitution. Okay, we know that they're complementary, so they add up to 90. There are a lot of things you could put right there. All right, now I know that AED plus AEC equals 180. How do I know that? Ooh, you have to be careful. We're trying to prove that this is 90, so we can't use that. But whenever two angles create a straight line, then they add up to 180, right? So this says definition of supplementary angles. If two angles are built on the same line, and you know they represent the entire 180 degree rotation of that line, then they're supplementary. Okay? So, what are we going to put for 6? So, I already know that this one is 90. Right? So, 90 degrees, no wait, the other one. Yeah, sorry. I've already shown that this one is 90. So the measure of angle AED plus 90 degrees is equal to 180 degrees. Does that make sense? So what is the reason behind the last step? Subtract 90 from both sides. Exactly. So the explanation behind number 7 is subtract 90 degrees from both sides. And my smartboard just died. Okay. All right. What I would like you to do is number 2 and number 3. So on your own, try to do number 2 and number 3, and we will talk about them tomorrow. Okay, because we have an assembly at 9:22. Now, 2 and 3 are, you don't have any help. You need to come up with your statements and your reasons all on your own. Okay? All right, get to work.